Hello there. So today I'm going to be talking about event queues. Okay. So basically when an input generates an event, it goes to a queue, and this queue is basically what we call an event queue. So the queue has a bunch of in-process events from which the oldest event would be performed in an application. So basically what this is like, it's like when it's like a lineup to something. The first person in line gets whatever they need first, rather than the people after him. So, so there are a couple of problems with this in a sense. So one being the system blocks the caller until the engine has completely processed the event request. So it's like when an audio system processes another play sound, it wouldn't really play the second sound unless if the first one is done. Then the second problem is requests cannot be processed in aggregate. So what this means is that it can't mix the requests together to perform efficiently. So let's say the first audio is there's a first audio and then the second audio, but both of them are just the same audio clip. It cannot combine both so that it performs at the same time, if I'm explaining it right. So the third problem is that requests are processed on the wrong thread. So let's say, like, ideally in a multi-core system we have each thread for each component, right? So sometimes requests are like sent to a different thread, and that is a problem because it's not really optimized to perform such task. Basically all of this, the main problem is that the immediacy. So yeah, basically systems call the request when it's convenient for them, not when it's convenient to the actual system. Can't explain it. Yeah. So basically what this means is that the event queue process it when it's convenient for itself, not for when it's convenient to the system that requests it. There you go. So the pattern. So the pattern for event queues is basically a queue structure, a first in, first out. So like the lineup analogy that I talked about earlier. So this means that requests can't be handled directly or routed to interested parties. So this separates the sender from the receiver both statically and in time. That's what it is. And then usually event queues are global variables usually. This pattern is usually used as a central event queue, like a main hub for events, right? Connecting all parts of the game through loop messages. So loops. So a queue is a synchrony unwinds the stack, so the game will keep running even if the events are going back and forth. We might have to watch this because we don't really want nesting requests. So let's say this request has something inside and then it just goes back. We don't really want to get stuck on the same loop when there's other stuff that's going back at the code. So to avoid this, we should avoid like sending events that already has a code that's handling something. Yeah, that's all about it. So how to do event queues. So basically what we have to do is that we have to call Yeah, so basically what we have to do is have a call that can be deferred until later. Yeah. And then we have a little structure. We need to have a little structure that stores the details of that request for later time. And then the second step is to give the system some storage to keep track of the pending requests. So yeah, you want to have a list, basically. I mean, a container of where to keep the pending ones, right? So the third one is to give the callback to the sender. So the update is where this would ideally go. Then the call, and then call this update somewhere on your main game loop or whatever main handler that you have. Yes, this is my sample code from the example. So first up, the number one is here, so it has a struct for the message. So this is a structure that can keep all of the information for the request for later on. And then the second one is the system to store it. And then the third one, which is over here at the class audio, it's when it's calling the stuff that goes in the loop. Oh, I'm garbage. But yeah, that's about it for event queues. Bye. Am I not recording?